This podcast is brought to you by StarCharge, the largest EV charging manufacturer in the world, and is also a provider of residential and commercial battery storage and microgrid solutions. And Kempower, the reliable, quick, and scalable EV charging solutions for everyone and everywhere. Hey everyone, it's Francie here, welcoming you back to another episode of the Out of Spec podcast. There is a tree outside of my window at my home just waving at me in the wind with its beautifully pink blossoms that are blooming right now. They were just buds a few days ago. Can you believe it? Is spring already here, or is there another cold snap incoming? The groundhog, I know, did not see his shadow, so that points to an early spring. So perhaps that is what we'll see. I know that there is a big windy weather trend rolling through the country today. I've heard that from a few friends in a few different states, which is a perfect segue into today's topic, all about air and aerodynamics and efficiency. Automakers are on a quest, most of them at least, for efficiency with their electric vehicle designs, models, technology, because that's what the market is looking for. That's where the competition is. That is a buzzword. Some approaches to improving efficiency include weight, reducing it, improving battery performance with new technologies or better technologies, and redefining aerodynamics. There's always optimization to be done, but like we'll talk about here, it comes with a price tag. Today, we are going to dive into how Hyundai and Kia Motors are going about it, at least in one aspect, with its active air skirt. Sounds fashionable. Let's dive in. One crucial aspect of efficiency lies in air management, the design of an EV and any vehicle for that matter. And this can significantly impact its aerodynamic efficiency, which of course ultimately affects those delicious specs that we're always looking for: range, performance, efficiency. So by working to streamline airflow around the EV, automakers can work to minimize drag and increase efficiency to improve their offering. Sometimes it's easier to do so based on the shape of the vehicle. Just think of your typical sedan versus a minivan or bus versus a sports car. Some of those are far easier to shape into an aerodynamic design than the others. Hyundai Active Air Skirt. So this is an electronically controlled skirt that lowers during high-speed driving to improve aerodynamic efficiency. So it's alive? No, but it does move on its own. It activates based on what's going on with the driving. So it controls the airflow through the lower part of the bumper. And of course, if it's coming down at higher speeds, that means that it is hidden during normal operation, but it deploys at 50 miles per hour. Why at 50 miles per hour, you might be asking? Well, this is when, according to Hyundai and Kia Motors, their research, this is when the aerodynamic drag is greater than the rolling resistance of the vehicle. It comes down the skirt and covers the area in front of the wheels, but not the entire front of the EV. It is designed with their EGMP platform in mind. Unsurprisingly, of course, they have really had this comprehensive approach of building from the ground up with their EV offerings, and we've been pretty excited to see what they're doing. It seems like they're kind of shaking up the industry and coming out with some really great offerings to the market. The Out of Spec team up in Fort Collins, Colorado, does have an EV9 loaner from the local Kia dealer, which is really cool. We've been doing some testing on it that you'll see coming up. So stay tuned to the Out of Spec reviews channel for all of that EV9 info. We also have an old podcast from an EV9 owner, perhaps one of the first in the Northeast of the United States. So we will link that in the description as well. So how does the physics and aerodynamics work here? I'm neither a physicist nor an aerodynamicist, but the skirt is made from rubber material, so it's durable. There's a low risk of damage, so that's great. And the deployment of it adds downforce and stability at high speeds, and even at speeds over 120 miles per hour, they say, which is surely not a speed that most of us will be driving on a typical drive in our Hyundai, Genesis, or Kia EVs. But according to their research, they used a Genesis GV60 with the active air skirt, and it improved the drag coefficient by 0.008, which is about a 2.8% improvement. And in the Genesis GV60, this is about 4 miles of extra range per charge. This is very small, obviously. 4 miles? I mean, you likely wouldn't notice 4 extra miles of range, right? What do you think? We have to think, of course, big picture as well, because maybe it all adds up in the grand scheme of things with the many ways that you can get just a little bit more efficient with the EV design. And we have a podcast coming soon about the Porsche Taycan facelift. And of course, this is a different automaker with a different budget, perhaps at least distinctly different, that seem to do everything in their power, their team, to improve the efficiency at absolutely every level possible. And of course, they worked on battery technology improvements and charging as well, but they also seem to really shave off or add on a lot of things that improved the efficiency of the EV with some impressive stats. And this, of course, is a seemingly essential part of building most the most efficient EVs on the market. Every level trying to figure out what you can fix, add, edit, delete to increase range. But back to this example. Okay, so if we think about it, the active air skirt can add 4 miles to one charge. Cool. EV specific tires, these can improve efficiency as well as wheel size. The careful design of spoilers and mirrors and bumpers can improve that drag coefficient as well. By the way, you might see this written as capital C, lowercase d, drag coefficient. Wheel covers have also been known to give a few more miles. And of course, the exterior body panels can be optimized all the way over to the motor and the inverter designs optimized to increase efficiency. Yes, each change on its own seems minor and doesn't make an appreciable difference, perhaps. But when you add them up, you might get the most out of the vehicle. Suddenly, you might have an extra 20, 30, or 40 miles of range, which could make a big difference comparing it, especially to other models and other EV options out there. And either way, it is cool. And it's probably great work on the engineer's part to get the most out of the EVs that they're designing. And I'm sure the team is just in the space is a haven for creative thinking, problem solving, and engineering, if you ask me, which you didn't, but you're not here. So I asked myself. And it makes me curious, makes me wonder where else they could actually improve. The air skirt is actually adding on something. So is there more things that we can add to the EV to make it more efficient? Should we just get rid of all the weight possible? Is there any more low-hanging fruit that they can take advantage of? I don't know. What do you think? Probably not. What comes to mind for you? And when do you say, as an automaker, hey, listen, we grabbed all the low-hanging fruit, all the middle-hanging fruit, but maybe we just need a ladder? Maybe we just need more charging, more EV charging all across the roads in general to make it so that 40 miles more on a range isn't that big of a deal because no matter where you pull off, you'll have a charger to help you charge up and get to wherever you're going. Put less pressure on optimizing range and more pressure on reliable, consistent, ubiquitous EV infrastructure. Where does a manufacturer draw the line on improved efficiency and practicality and cost? Like we mentioned at the beginning of this podcast, it's not simple or cheap to experiment with the ways to improve the efficiency of an EV. The Porsche example I mentioned, Kyle, I think he mentioned on the podcast the magnitude of the investment that went into this, perhaps, or at least the many different aspects that were invested into to make things better and better. And this kind of investment it just isn't feasible for a lot of automakers, or maybe it just doesn't present itself as a solid business case for most other automakers, I'd argue. There's examples like pure silver that's technically more conductive than copper, but we're not going to replace all the copper wires with pure silver. And carbon fiber is a material that is far lighter than aluminum, which is used widespread in this industry, but it's expensive to make and it's not really easy to repair and it's not super practical for mass market vehicles. Still, the research and development, as well as the building of the motors and the actuators and the parts for the active air skirt that we're talking about here, couldn't have been cheap. So companies are clearly willing to spend some money for modest efficiency improvements, 4 miles, which is why I find this story interesting. And another example of how automakers are going to many, many lengths to figure out how to approach efficiency when building their EV offerings. And it makes me think as well of the the Mercedes EQXX, an ultra efficient prototype from Mercedes, where they pulled out absolutely all the stops just to see how efficient they could make a vehicle. And of course, money was poured into that. And it was probably a great way to experiment and learn where they can practically make improvements and what technologies are worth investing in and which ones should be scrapped, and put it all on one model and see what happens. And I'm sure Mercedes is not the only manufacturer who had this idea or will have this idea. And I think it is an interesting approach. There's a lot of ways to go about it. Of course, the price starts to weigh in and the budget for the research and development. Perhaps, just some automakers will figure it out and then other automakers will adopt that design, that example. But I do think it's a bit hard just given the nature of EVs to pull out every last mile that you can without significant advancements in battery technology. That's kind of my thought. What do you think? Is there clear options for improving efficiency? Do we really need to stop worrying about adding 20 to 30 to 40 miles of more range on EVs and just focus on the EV charging infrastructure? Let me know what you think in the comments. Really appreciate y'all plugging in with us today for another episode of electric coverage of the electric vehicle space. If you're new here, welcome. If you're not new here, welcome back. And if you're liking it, please like and subscribe to our YouTube channel. Feel free to go over and follow us on Twitter. And of course, check out the other Out of Spec channels as well. If you're interested in car reviews or road trips, we have different channels. Thanks for tuning in. I hope you are going to have a lovely and blossom-filled rest of your day or week. And I will catch you next time on the next episode of the Out of Spec podcast. Bye-bye, y'all.